Hello, hi, good afternoon and welcome. So good afternoon all. Today we are going to learn about distance time or position time graph. But before we do that, let's understand why we need to learn about this graph. What is so much importance about it? Okay, so let's learn that first. So we'll learn about the importance why the graphs are required, and then we'll go to the distance time graph. Okay, this is about me. If anyone is new here, I have PhD in physics from Singapore, BSMS dual degree from ISA Pune, as ranker in JEE as well as KPY. Alright, let's begin. If you are watching this, just shout out hi so that I'll know you're there. Hi Lalit, good afternoon. Great. Let me just zoom in just a minute. Alright. Lalit, Jain, Devanshi, good evening everyone. So in the last class we have learned about what is velocity and acceleration. I hope you guys remember this formula. This is for the average velocity. Average velocity is total displacement divided by total time, and acceleration is the change in the velocity divided by time. That will give you the average value of the acceleration. Hi Sumitra, good afternoon. Now let's understand first why the graphs are so much important. I'll show you one very quick graph. How many of you like IPL or cricket in general? Do you watch these IPL games? So let's suppose there is a data. There is so much data in a single graph. This is for the T20 cricket match. You can see here from 1 to 20. So these are the number of overs, and what is on the y-axis? These are the number of runs. So in every over, how much runs are scored? So in a single graph, you get so much information, right? If I write a paragraph, will it be interesting to read such a long, lengthy paragraph? Obviously not. You wouldn't like to read, correct? But here, just by looking at a single graph, you understand so much data. So that is why graphs are important. And what are the advantages of graph? First is it makes the data more presentable. So you can present the data more quickly and easily. So the learner who is observing that data will understand it very quickly, very fast. It eliminates language barrier. So in this graph, you see there is not much English. You can use the same graph in whichever language you are comfortable. You can still understand almost all of the data, correct? Hi Ashutosh, good afternoon. Then visuals are more effective, obviously, than the text. Helps to summarize a large amount of data, right? And it is a better comparison. So you can compare between, let's say, over number 1 and over number 2. In first over there are 14 runs scored. In the second over, just 1 run scored. So you can compare. So it is very useful to have this graphical representation, right? So before we go to the distance time graph, first we need to understand little bit of geometry. That is very much important. थोड़ा हम maths पढ़ लेते हैं, क्योंकि maths क्या होता है? Maths is like a tool. We use it in physics. If you are good in maths, your physics will definitely be very easy. Even if you are not very good in maths, you don't have to cover everything. Only will take some portion or some part जो हमें चाहिए, सिर्फ उतना सा maths हम सीखेंगे and हम directly apply करेंगे, है ना? Let's begin. So now these are the x coordinates and these are the y coordinates. So you can plot them on a graph paper. So how do you plot? This is, you know, this horizontal line is your x axis and the vertical line is your y axis. So you can plot when x value is 0, y value is 2. So it is this point. So similarly you can plot other points and you see that it is a straight line. So whenever you get a straight line, then you get one very important property that is called as slope. And what is slope? Slope is nothing but rise or fall divided by run. So this is how you calculate the slope from a straight line or straight curve. So for example, here there is also a straight line. You can see here it is increasing. So if it is increasing in the y-axis, we call that as a rise. So how much rise in the y coordinate? If it is going down, we call it as a fall, right? So rise or fall, that is nothing but our change in the y coordinate. And this is a run. So how much the x coordinate has changed? That is change in the x coordinate. If you take this ratio, you will get the slope. So m is a symbol for slope. So this is how you calculate slope of a straight line. And I'll tell you why it is so much important to understand how to calculate the slope. But before that, let's do some easy calculations. So you will understand, you will get a better understanding about what is the slope and how it is calculated. Okay, थोड़ा सा 2-3 क्वेश्चन सॉल्व कर लेते हैं, बहुत सिंपल, बहुत इजी. You can type the answer in the chat so that I'll know you are able to understand. The first one, solve this one, first question. First one. So here, you see here, this is a 3 and 3. So how do you calculate the slope? Slope, I'll write down formula here. Slope is nothing but change in the y coordinate. So that would be either this one. There is change in the y coordinate. There is rise or fall, correct? So how much it is? It is going upwards. Going upwards, that is a rise. So if it is going upwards, we call this as a positive. So it is plus 3 and then it is divided by run. So what will be the slope? Slope is plus 3 divided by plus 3. That would be 1. So slope of this first graph is 1. So similarly, can you tell me the slope of other two graph? Okay, all right. Slope is tan theta, nice. So how will you find out slope of the second graph? So for here, the slope would be again change in the y coordinate, that is 4. This is divided by change in the x coordinate. What is x coordinate? 2. Change in the x coordinate or run is 2. So 4 divided by 2 is 2. So this is how you calculate the slope, correct? And for the third one, the slope is again change in the y coordinate, that is our rise, which is plus 3 divided by 5. So 3 by 5 or 0.6 is the slope. Easy? So how many of you feel it is very easy, very simple, and you can solve these kind of questions? If you feel it is easy, then solve the next 3 questions. Solve this one here. So now in this case, it is going down. You see the arrow? Arrow is pointing down, right? So how will you find the slope? Slope is rise or fall. In this case, it is fall. Fall means it is negative. So it is minus 4 divided by 2. Run is the same, 2. Minus 4 divided by 2, which will give you minus 2. So that is the slope of this graph. How about the next one? Now, can you tell me, is any rise or fall? Any rise or fall? So here, no rise or fall. If there is no rise, so it is not increasing. The y coordinate is not increasing nor reducing. So in that case, rise or fall is 0. So if the rise or fall is 0, then the slope of this graph is 0. Nice, Devanshi. Physics QWERTY. Nice, correct. How about the next one? In this one, the rise, can you tell me if it is the rise of 3 or fall of 3? Can you tell me? Who can tell me? If it is increasing by 3 or decreasing by 3? We can't say, na? Here it is very difficult to tell if it is going up or coming down. So the slope you can write it as Okay, we don't know if it is going up or coming down. We don't know. So because of that, the slope m, you can write it as plus or minus 3 divided by 0. So the run in this case is 0. So anything divided by 0 is not defined. So for this graph, slope is not defined. So whenever the x coordinate does not change, then we say in that case slope is not defined. Correct? Slope is infinite, but you don't know whether it is going to be positive infinite or negative infinite. Correct? Can you tell me? If it is plus infinity or minus infinity, you can't say, na? So that is the reason slope is not defined here. Okay? Yeah, anything divided by 0 will give you infinity, but it could be plus infinity or minus infinity. So the slope is not defined. Clear? Now, so we have learned if the graph is going down, so it is like a going down the street, so the slope would be negative. If it is flat, not increasing, not decreasing, then the slope is 0. And if it is going uphill, then the slope would be positive. Correct? Just remember this. So you can solve lot of questions, lot of easy questions, and lot of them were asked in NTSC or Olympiad exams as well. So you should be very careful while writing the proper sign of the slope. Alright, so now let's come back to our topic, that is a distance time graph. So here we have two variables. There is a distance and there is time. So if you have two variables, how do you choose? We have a graph. Graph will have the x coordinate and it will have the y coordinate. So which of the two I should plot on the y and which of the two I should plot on the x? How will you decide? We have two variables, distance and time. So in that case, no, I will not discuss calculus. We will see. Right now, no plans of discussing calculus. Slope of a curve, we will discuss that in the next class. Okay, Ashutosh? Alright, what I was saying? Yeah, here we have two variables. So whenever you have two variables, you need to understand which one is dependent and which is independent. Independent is something which is free, which is not dependent on anything. So the time is always going to be, in 99.9% cases, time is going to be independent variable. I have a clock, you also have a clock. Time is always running forward for everyone. Time doesn't stop, correct? So when the time is going forward in like normal Newtonian mechanics, so we consider time as an independent variable. So whenever it is an independent variable, we put it on the x-axis. So this will be our time. So what should be on the y-axis? Anything which is other than time, which is, for example, here distance. So distance will go on the y-axis. So this is why we call it as distance time graph. Clear? Yes, so this is what I have written here. Time is taken along the x-axis because time is independent variable. Time does not depend on any other quantities, but the distance will depend on the time. We say at time t is equal to 0. So there is a starting point, or time t is equal to 5 minutes. That is, let's suppose, the end of the journey. So we consider time as a base, and with respect to time, we find out what is the distance travel. So distance will go on the y-axis. Is it clear, everyone? Alright, sometimes instead of distance, we can plot position as well. Sometimes it can be position. So for example, if it is a x-axis, the particle is at x is equal to -2. When time is equal to t is equal to 0, particle is at x is equal to -2. Then it started moving and went to the x is equal to, let's say, +5. Correct? So this is the position of the particle. How the position change with respect to time. So this distance time graph you can consider as a position time graph as well. Clear? Okay, now time is constant and distance is changing. Is it possible? Time is constant, so you have to freeze the entire universe. If you say time is constant, that means you're freezing the time. It is very difficult. So if you learn the Einstein theory, so in that it is possible that time could be constant, but other than that, time is never going to be constant. Okay, so now you see here there are two cars. There is a blue color car and a red color car. And what is plot? There is a position of the car versus time. And how it change? The red car overtakes the blue car. So what does it tell you? The blue car is faster. Blue car runs faster. Sorry, the red car runs faster. Blue one is a slower car. Can you see here from this graph? The slope of blue line is lower. Slope of the red line is more steeper. So we say that slope is directly proportional to the velocity. Or if you have position versus time graph, then if you calculate the slope, you will directly get the velocity of the graph. Clear? Yes, slope of the distance time graph, you will get the speed or the velocity. Correct. Nice, all of you. You guys are awesome. So this is how we calculate the slope. There is a distance in meters, time in seconds. And how will you calculate the slope? Slope is nothing but rise divided by run. There is a slope, rise divided by run. But what is rise? Rise is our distance. Rise is nothing but change in the position or distance traveled. So there is a distance divided by what is run? Run is the time measured in seconds. So the slope is distance by time. What is distance divided by time? It is nothing but slope will give you speed of the object. Clear? Slope will tell you the speed of the object. Again here same distance divided by time, you will get the slope as speed of the object. Is it clear? Sometimes I am saying it is velocity, sometimes speed. So why there is a difference? Here you see if it is distance versus time, you will get the speed. If it is position versus time, then you say that it is the velocity. That is the proper definitions. But sometimes the person who make this graph, they don't consider so many details and they just write distance versus time. So distance, it cannot be negative, but position, it can be negative. Similarly, speed, it cannot be negative, but velocity, it can be negative as well. So we'll learn all these cases. You see here, these are the different distance time graph. And can you see the first one? This is a position, sorry, this is a position versus time graph. So position is same. That means the object is standing at the same place. For example, if I am standing here, not moving at all, if the particle is not moving, the position will remain constant. The position remain constant as a function of time. That means object is at rest. Object is at rest. So zero velocity and zero speed. Now this is again position versus time graph. So position is increasing with time. Position is increasing with time. That means if I plot this our x-axis, the object is going towards positive of the x-axis. This is our x-axis. This is positive direction. So position is increasing with time. If the position is increasing with time, can you see the slope? Slope is positive. So slope is positive. If the slope is positive, that means the speed or the velocity are like would be the correct meaning. So velocity here is going to be positive. So it will have positive velocity. If you take the magnitude, only the number, only the value of the velocity, you will get the speed, right? Now here the position and time, what is happening? Again, if I plot, there is a x coordinate, x is equal to let's say 10, object is moving to the negative direction. let's suppose there is a x value 10 and there is a x value, let's suppose 2. So it has traveled from x is equal to 10 to x is equal to 2. So what happened? Object is moving towards left, towards the negative value of the x. So in that case, the slope is going to be negative. So again, the slope is negative, hence the velocity will also be negative. Velocity is negative, but it is still a constant velocity. Why it is constant velocity? Because the slope of a straight line is same. The slope of a straight line is a unique number. It does not change. So velocity is constant but negative. Or speed, you can say speed is the fixed number. So whatever it is, let's suppose time t is equal to 0 here and t is equal to 8 seconds. You can calculate the speed as well. So what will be the, let's calculate velocity first. Velocity will be change in the y coordinate. There is a fall. Fall is, there is a final value 2 minus 10. So 2 minus 10 divided by, what is the run? This is a run. What is the change in the time? It is 8 seconds minus 0. So that is simply 8. So this will be minus 8 divided by 8, which is minus 1. It could be in meter per second. That would be the velocity, minus 1 meters per second. It is a constant number, okay? But the speed, just remove the minus sign. Speed will not have positive or negative. So the speed for this case will be plus 1 meter per second. Clear? We have to consider negative displacement for numericals in school. Yes, if it is negative, so we consider it to be negative. If it is positive, we consider it to be positive. Clear? Yes, the last curve, I'll choose some other color. Here, what is happening? Now, if you choose different points, let's suppose I consider these 4 points A, B, C and D. These are the 4 different points. So at every point, every location, what we do is we find the tangent at every location. So at this location, this will be the tangent. At, let's suppose B location, this will be the tangent. At C, it would be this tangent. At D, it is this tangent. So what do you observe? As you go from A to D, the tangent is becoming steeper and steeper. So what is this tangent? The tangent will give you instantaneous slope. Instantaneous meaning at that particular point. So what is happening? The slope is increasing. For this case, slope is increasing. Slope is increasing. This is position versus time graph. That means if the slope is increasing, that means velocity is increasing with time. So the velocity is increasing with time. And if velocity increase, what kind of motion it is? It is an accelerated motion. So there is a positive acceleration in this case. So acceleration will keep on increasing with time. Clear? Yes, nice. QRT, Y physics, correct. There is a uniform and non-uniform motion, correct. These are the uniform motion, this one and this one, and the last one is non-uniform motion. Clear? Awesome. Position is the displacement. Yes, Sumitra, position will tell you the displacement of the object. Clear? Any questions, anyone? Easy, right? So let's solve some few easy questions. MCQs. I know you all like MCQs. Let's solve those. Okay, this is a summary of all the different types of graph. So I'll quickly tell you what are the different types of graph. From this origin to this is a steady speed. Can you see steady speed? It is a straight line. So wherever you get a straight line, that means constant speed. Straight line, constant speed. This one, steady speed. Here, again a straight line, but it is going down. Again, the speed is constant, but velocity is negative. So returning to 0 point, speed is constant but velocity is negative here. You like physics? Nice. 76 colors. Is this? Yeah, that last one was non-uniform. I'll again repeat here. So this one is a stationary. Stationary meaning at rest. If the position or the distance of the particle is not changing with time, the distance is not changing or position is not changing, that means the object is at rest. Clear? Now we have 3 more graphs. So what do you understand from here? This green, can you see it is a straight line? Again a straight line. Straight line means again constant speed. So this is also constant or steady speed, but it is faster. Higher the slope, it would be faster, right? So green is faster than this red. Red is a slower. This green is more steeper, so it is faster. And we have this one, blue one. So what is happening here? You see the slope is increasing, or the graph is becoming steeper and steeper. The graph is becoming steeper and steeper. That means the speed is increasing with time. So there is a accelerated motion. There is a constant acceleration. It can be constant or not constant, but it is accelerated motion. Clear? Or non-uniform motion. And the last one, can you see this yellow one? So it is slowing down. Why it is slowing down? You see the steepness? The curve is more steeper here, but as the time increases, curve becomes lesser and lesser steep. So what does that mean? If it is becoming less steep, that means the speed of the object is reducing. Speed is reducing. I am using the word speed. Don't use the word velocity. Speed is reducing. So that means the magnitude of the velocity is decreasing with time. For this graph, magnitude of the velocity, that is nothing but the speed, is decreasing with time. So that is nothing but our retardation. Retardation or negative acceleration. Clear? So this is a summary of different kinds of distance versus time graph. Clear? Now solve few questions. Yeah, velocity time graph we'll learn in the next class. Velocity time, acceleration time we'll learn in the next graph. Why speed? Okay, why I'm using the speed here? I'll quickly tell you about this. Let's suppose if I draw a graph here. So this is the graph. Something like this. There is a position versus time graph. So what is happening? Now you can choose 3 different points on this graph. Let's suppose this is point A, this point B, and this point C. So at these 3 points, what you do is you draw a tangent. So there is a tangent number 1, there is a tangent number 2, and there is a tangent number 3. So what do you find? You find that the tangents are becoming less steep. But all these tangents, the slope would be negative. Can you see? The slope is going to be negative. Let's suppose the slope is here m1, m2 and m3. These are the 3 different values of the slope, and all 3 of them are negative values. So m1, m2, m3, m1, m2 and m3, all 3 of them are negative. So that will tell you the velocity at all these points is going to be negative. So at all these points, velocity is negative, right? Velocity is negative. But if you find the magnitude, just the magnitude, what is the magnitude of the velocity? It is the speed. So speed at this point A is much greater, because although it is negative, if you take the magnitude, let's suppose I'll give 2 numbers, -3 and -5. These are the 2 negative numbers, and if you take the magnitude of this, so magnitude will be 3 and 5. Magnitude will ignore the sign. So we just have to ignore the sign. So this will be the speed of the object. Whatever values. Let's suppose it is meter per second. If the position is in meters and time is in second, so this will be 3 meter per second. This would be 5 meter per second. This would be the velocity values. These are the velocities. So this would be minus 3 meter per second and minus 5 meter per second. Understood now? How to convert from velocity to speed? You ignore the minus sign. You ignore the sign, then you get the speed. Now it is clear why the speed at A is greater than speed at B, than speed at C. So all these things you understand from the position versus time or distance versus time graph. So let's solve few numericals. Slope describe the speed, correct? Yes, Mark, correct. Mark Anand, nice. Bimla Kumari, correct. A, okay. Alright. So what is the question? Which of the following figures correctly represent a uniform motion of a moving object? So object is not at rest. So here there is a distance time, but it is a flat line. Flat line means object at rest. So this is not correct. It will tell you the object is at rest. How this one? Here it is a curve, not a line, not a straight line. So whenever you have a curve in a distance time graph, then it is a non-uniform motion. So this is not uniform motion, or the speed is not constant. How this one? Again it is a curved. Curve meaning non-uniform motion. So again this is not correct. And how this one? It is a straight line. So if it is a straight line, that means it is a uniform motion or constant speed. So that is the correct option. Nice, all of you. Devanshi, Sumitra, Sneha, Ashutosh, QRTY Physics, A, VV, Vinay, nice, awesome. Solve this. This is a very interesting question, solve it. Which of the following graph is not possible? Option A, it is position versus time. Option B, it is velocity versus time. Option C, acceleration versus time. And option D, position versus time, which is not possible. And nice, some of you got it correct. Homeo Bhava exam. Okay, I need to check about it. I don't know much about this Homeo Bhava exam. I'll check and we'll figure out. Okay, Ashutosh? Yes, option B is not possible. Why? Because what is happening here? For the same time, you have two different values of the velocity. For the same time, object cannot have two different values of the velocity, right? That is one reason. Another reason, let's suppose if you start from here and go in this direction, and let's suppose reach to this point, after that what is happening? You have to turn back. You have to go back in time. That is not possible. We don't go back in time, right? At least in real case, real world, we cannot go back in time. So until we don't figure out the time machine, this graph is not possible. Alright? Yes, time cannot be reversed. Nice, Ashutosh. Solve this. So which of the following distance time graph shows a truck moving with a speed which is not constant? Speed which is not constant or non-uniform motion. So which of the following will tell you the non-uniform motion? You guys are awesome. Nice, Ashutosh, Sneha, Devanshi. QWERTY physics, Vinay and Smitra. Awesome. This option C, it is not marked, but this is the correct option. Nice. This is not correct. Why? Because it is a straight line. That means a uniform motion. Again, there is a straight line, so uniform motion. There is a flat line. So object at rest. Object is at rest. These two are uniform motion. There is a non-uniform motion, so speed is not constant. You guys are learning. Nice, nice. Nice to see that. Clear, anyone? Any questions? Any questions, anyone? Solve this. So choose the correct option from the following. 4 cars A, B, C, D. So what do you observe from here? This is again distance versus time graph, but they have different slope, different steepness. So you have to understand which is more steeper or which graph has a more slope. Okay, option B. All right, let's find out. So here we have 4 different car. The C graph for the car C is steeper. So C will have the maximum speed. So I'll write the speed of these 4 cars as follows. C is greater than D, which is greater than A, and this is greater than B. B will have the least slope, and that is why the speed of car B is the least, or B is the slowest one. So let's read the options. Car A is faster than D. Is A faster than D? No, D is faster than A. So this is wrong. How this one? B is the slowest. That is correct. Car B is the slowest one. How the next one? D is the faster than C. No, C is the fastest. So this is also wrong. How the last one? C is the slowest. Again not correct. C is the actually the fastest car. Clear? Easy? Nice. Solve this. So C is this graph, this one. So tell me what is happening at point C or graph number C. Which of the following is correct? Okay. Okay, you guys are thinking it is B. B is accelerating. All right. Let's find out. This is our graph C. So what is happening? For this graph, the slope is increasing. Can you see? The slope is increasing. Graph is becoming steeper and steeper. That means the speed is increasing or the velocity is increasing. So if the speed of the car is increasing, what does that mean? That means the object is accelerating. So option B is correct. These two are not correct because it is saying steady speed. It is also saying steady speed. It is not a steady speed. Steady means constant speed. This is not a constant speed, and again not a stationary. So only option B is the correct one. Now this is your homework. You can solve it. You can type in the comments and we'll solve this question in the next class. Next class is today's Tuesday. So tomorrow I have grade 10, then Thursday. Yeah, Thursday we'll have again grade 9 class and we'll solve this question on Thursday. So bye bye everyone. Take care. Hi Rohan. Thank you so much. You get all these notes on this Telegram channel. You can follow. Any questions? Nice. QWERTY. We'll solve that same question on Thursday. So let's meet again on Thursday 3 p.m. sharp. Alright, bye bye. Doubt? Okay, you have doubt. What is your doubt, Ashutosh? What is doubt? Type fast. Or else you can comment your doubts in the chat. I'll solve all your doubts in the, you commented? Okay, doubts. Sir, distance traveled by a freely falling body is proportional to. We are going to learn the object which is under accelerated motion. So if the object is falling under gravity, that is the accelerated motion. So we are going to learn the equations of motion, and in that you'll learn more clearly, more specifically how the distance change with respect to time once we learn the equations of motion after 2 classes. Okay, so I'll give it roughly. So if it is accelerated motion, distance is proportional to time square. But we'll learn that in couple of more classes after 2 classes. Bye bye everyone, take care. See you again in the next class.